All right, can you raise your hand if you can hear me? Okay, perfect. So let's get started. So we all use and build applications. And all these applications, they run on a network, even if we are in the cloud. So as an AWS customer, it's very important that you have strong network foundations and foundations that are aligned with your application's requirements. So things like security or resilience. So today in this session, we are going to see how you can design well-architected networks on AWS. My name is Vincent. I'm an AWS Solutions Architect, and I will be joined today by Adam, who is a Principal Solutions Architect specialized in networking. So let's get started. So this session will be a 200-level session. So it means that we will talk about the fundamentals, but we will not start from the very beginning. So the goal of the session is really to give you best practices on how to well architect your networks on AWS. You will see throughout the presentation a bunch of QR codes. So they will appear from time to time, and they will be there to give you links to the documentation or to other sessions so that you can dive deeper in some topics after this presentation. And finally, you will also see from time to time our well-architected cat appear. So he will be there to give you tips and tricks about networking configuration. So let's start with the fundamentals, and let's talk a bit about Amazon Virtual Private Cloud. So first thing you do when you begin with AWS is to pick a region. And a region, it's simply an AWS a location, a geographical location in the world where AWS is present. And so as we are here at the AWS London Summit, I guess the majority of you will choose the London region, which is EU West 2. So within a region, you have multiple availability zones. And inside of each availability zone, you have multiple data centers. So availability zones are totally independent from each other, and they are separated by a meaningful distance. But this distance is not too large, so that we still have high bandwidth and low latency between two AZs. And then on top of this infrastructure, what you can do is to launch your virtual private cloud. So this is really your private network within AWS. And first thing you have to do when you launch your VPC is to give it an IP range. And so you can have IPv4 and IPv6. Now, VPC, as you can see, it also spans multiple availability zones. Now, within the VPC, what you typically do then is to launch subnets. And the subnets, they are really the places where your application, your workloads will live. So things like EC2 instances or RDS databases. And as you can see, a subnet, it's really local to an AZ. And you can have dual stack subnets, but you can also have IPv4 only subnets or IPv6 only subnets. And you see that here we have an application architecture that uses some of the basic networking constructs. So now we have the first appearance of our cat. So he's going to give you some tips and tricks here. So first we recommend dual stack. So why? Because then you have the best of both worlds. So you are still compliant with IPv4 and you are future-proof for IPv6. Then as we use here multiple AZs, you have to know that there are charges if traffic crosses multiple AZs. So we always advise to minimize cross-AZ communication. And finally, if you use multiple AWS accounts, you have to know that the AZ name, like EU West 2A, can be mapped to different physical AZs in different AWS accounts. So if you want to have more consistency, what you have to do is to use the AZ ID instead, and the AZ ID will always map to the same physical AZ consistently within many AWS accounts. So now let's have a look at another situation. Let's talk about internet access. And let's say that this instance here wants to talk to the internet. So what we have to do to enable this communication is to attach an internet gateway to the VPC, and then we will manipulate the route table of the subnet so that we have a default route that points to the internet gateway. So for IPv6, it will already work like that. You don't have anything else to do. But for IPv4, as you can see here, we have a private IPv4 address. So what you will have to do to enable communication with the public internet is to associate an elastic IP to the EC2 instance. And then what will happen from here is that the traffic initiated from the instance will be source NATed at the internet gateway level from this private IP address to the public elastic IP. Other situation could be with a with a private subnet this time. And what we want in this case is that the internet cannot initiate a connection to the EC2 instance, but we want that the EC2 instance can initiate a connection to the internet to, for example, download a security patch. In this case, what we advise is to use the NAT gateway, and the NAT gateway is always placed in a public subnet. And then what we do is that we manipulate again the route table of the private subnet this time to force the traffic through the NAT gateway before it reaches the internet. And in fact, in the same way here, traffic will be NATed now at the NAT gateway level from the private IP of the EC2 instance to the public IP of the NAT gateway. So this is for IPv4. Now for IPv6, if we have an IPv6 instance, we have another construct which is called the egress-only internet gateway. And here in the same way, we would manipulate the route table to force the traffic through the egress-only internet gateway before it can reach the internet. Now, a last feature I would like to illustrate on this slide is the VPC block public access feature. So it's a new feature that has been launched end of last year at reInvent. It's very useful for compliance reasons if you have many VPCs and if you would like to block all public access in a single click. So there are two flavors of this feature, so bidirectional or ingress only. So here on this slide, we illustrate ingress only. So it means that traffic coming from the internet, ingress to, for example, the instance in the public subnet, will be blocked, as we see with the red cross here. But traffic initiated from an instance, for example, in the private subnet, can still go egress to the internet. Last tips and tricks here. Create a NAT gateway in every AZ. So a NAT gateway, it's an AZ construct. So if you have multiple AZs, you need to have multiple NAT gateways, so one in each AZ to have high availability. Place only necessary resources in public subnet, so this is for your security posture in general. And use VPC block public access, as we just saw, so for compliance reasons. Now let's have a look at another situation, a bit similar, but here the challenge is that we have an EC2 instance that only speaks IPv6 and it wants to speak with a target on the internet which only speaks IPv4. So now we have IPv6 needs to talk with IPv4, so we need a way to translate between the two. So what we would do here is to use the Route 53 resolver and to enable DNS64. So what will happen then is that when the EC2 instance sends a DNS query to the Route 53 resolver, the Route 53 resolver will not answer with the IPv4 of the target, but instead will answer with an IPv6 address constructed from this IPv4. Now the instance understands IPv6, so now it will try to reach this IPv6 address. And then what we do is that we manipulate again the route table so that we force the traffic through the NAT gateway that will then NAT the traffic from IPv6 to IPv4 to finally reach the IPv4 target on the internet. So with that, we have translated between IPv4 and IPv6, and we have end-to-end communication. Now let's talk about elastic load balancer and some best practices here. So let's say that we have this VPC that spans multiple AZs, and let's say that we have targets in this VPC and in all the AZs. So what you can do is to launch a network load balancer. And so this load balancer will be materialized in the VPC as elastic network interfaces. From there, what you can do is to configure health checks between the load balancer and the targets. But then to reach the load balancer, it's done via DNS and Route 53, and you can also configure health checks at that level. So you see there are two types of health checks here, and our advice is really to always configure both types of health checks and test them regularly. Now, if we stay on this architecture, but let's say that we have a problem like too high latency on one node, let's say NLB node 2. So what you can do from here is to use another feature, which is called the application recovery controller, and you can manually start a zonal shift. So when you do that, what will happen is that Route 53 will remove the network load balancer node 2, in this case, from the DNS. And finally, only two AZs will continue to be used. So AZ2 will not be used anymore. So some advices here is to always pre-provision enough capacity, because if at a certain point you need to remove an AZ, then the two other AZs will have to absorb the same amount of traffic. And so it's good to pre-provision additional capacity in advance. Also, try to regularly test the feature. And what you can also do is to consider zonal auto shift. In this case, you as an AWS customer, you will delegate to AWS the responsibility to perform this zonal shift when there is an AZ impairment. Also good to know, and new from end of last year, application recovery controller zonal shift is now supported for ALB and NLB with cross-zone load balancing enabled. So yeah, here we see that we have discussed a bunch of best practices within a VPC and with internet connection. So now let's have a look at possibilities to connect VPCs together. So it can be useful if you have multiple applications, for example, in different VPCs that needs to talk with each other. So first feature we can discuss here is the VPC subnet sharing. In this situation, you would have multiple AWS accounts. And let's say that we have one special account, which is the central service account. And in this account, there is a central service VPC with a subnet. So the owner of this account can decide to share this subnet with other AWS accounts. And the benefit here is that each owner of each account can begin to launch their own services, like EC2 instances, for example, within this same subnet. And another benefit is that the owner of this central service account can decide to launch, let's say, shared network infrastructure like interface endpoints or Route 53 resolver endpoints, and they will be able to be consumed by all these EC2 instances. So here a remark is that it's not a multiple VPC setup, so everything is in the same VPC. So the level of separation between the workloads is less strict than if you would have multiple VPCs. And also, if you want to use this feature, make sure that the services you want to use, so that you want to launch within this subnet, support shared subnets. So you can have a look at this URL after the session to verify that. Now let's have a look at another situation. Let's say now that you have two separate VPCs and you want to connect them together. So the easiest way to do that is with VPC peering. And it's a good feature if you don't have a too high number of VPC, because there is a limit of 125 VPC peerings per VPC. But all in all, it's a really good feature if you want the highest bandwidth and the lowest latency between two VPCs. Now, a drawback is that you cannot insert, for example, firewall inspection between these two VPCs, because once they are linked via VPC peering, they will really begin to act as one. It's really almost like they are merged together. So it's something that is good to know. Other ways to connect VPCs together is with the transit gateway. And transit gateway, it's our cloud router, so it's highly scalable, highly available under the hood. And if you have one VPC that spans maybe multiple availability zones, as you can see here, what you can do is to attach this VPC to the transit gateway. Now, as a best practice, when you attach the VPC to the transit gateway, you will create a transit gateway ENI, Elastic Network Interface, in each AZ, and even you would have a separate subnet for each of these transit gateway ENIs. So if we do that for AZ1 and 2, for example, and if we have workloads there, the workloads will be able to reach the transit gateway and ultimately reach other VPCs. But now, if we don't do that in AZ3, for example, and if we have a workload there, the thing is that the workload will never be able to reach the transit gateway. So as a best practice, you always have to create a transit gateway ENI in each AZ where you have a workload. And so with the transit gateway, the benefit is that you can begin to deploy more advanced topologies. So here on the left, you can see full mesh between many VPCs. You can also have silos. So if you have development VPCs and you want that they can talk with each other, on the other side, you could have production VPCs and they can talk with each other, but you don't want to mix dev and prod. So silos could be possible. Centralized inspection is also possible. So if you want to have network firewall insertion, inspection between VPCs, you can do that as well. So with Transit Gateway, you can really go more advanced in terms of topologies. Now let's have a look at other requirements. Maybe you are multi-region and maybe you would like to connect two VPCs in separate regions. If you want to do that, what you can do is to use AWS Cloud One. In this case, Cloud One will be materialized by a core network edge in each of the region, and then you will be able to configure segments on top of that. And then you can attach VPCs, and here in this case, you can see that the two VPCs connected to the production segment will be able to talk with each other, but they are not able to talk with the development VPC. So there is a kind of isolation between the segments by default. What you can do as well is to attach a VPC to the inspection segment, and this could host a network firewall, for example. And Cloud One makes it really easy to configure network firewall insertion between VPCs. So if you have this requirement, please consider Cloud One as well. In fact, in terms of configuration, everything is done via core network policies, and it's basically infrastructure as code, so everything is configured in JSON. What you can also do is to attach or to connect your direct connect directly to Cloud One. So before an announcement that was made end of last year, you needed to have a transit gateway between Direct Connect and Cloud One, but now you can really directly connect your Direct Connect to Cloud One. So it simplifies the configuration in the end. Some last tips and tricks here from our CAT. So don't be afraid to use segments. So there are customers using more than 10, 15, even more segments. And also, if you want to use east-west inspection between VPCs, Cloud One makes the configuration really easy. All right, let's have a look at other requirements here. So let's say that you have two applications, client and server, and you want to enable cross-application communication. What you can do is to use another service called VPC Lattice. In this case, VPC Lattice will be materialized in each VPC by an endpoint. And what you can do from here is to register the server as a VPC Lattice service. So when you do that, the server will be able to enforce some credential requirements at layer 7 of the OSI model. And then if the client wants to reach the service and brings these authentication credentials at layer 7 of the OSI model, then the network communication at layer 3 will be allowed. So it's really a good service for most HTTP, HTTPS applications, and if you want cross-application communication. Now here you see that the communication is initiated from the client in the client VPC. But what if you would like to initiate the communication from on-prem? In this case, what you would do and what you can do is to replace this VPC lattice endpoint in the client VPC by a service network endpoint. So it's another type of endpoint, and you will be able to reach the server from on-prem as well. Let's have a look now at private link, which is another way to connect VPCs together. But private link can be combined with interface endpoints, and it will enable you to access privately, so only with private IPs, more than 150 services. So with private link, you can also access other services located in other VPCs, so typically provided by a SaaS provider. And provider VPC and consumer VPC can be in separate AWS accounts, can have also IP overlap, and they can now also be in different regions. Now we have another type of endpoint as well, which is called gateway endpoints. And these ones, they can give you private access to two services, S3 and DynamoDB. So what we advise here is to always maximize the use of these gateway endpoints simply because they are free of charge. Otherwise, on a more general note, use endpoints if you want to reduce data processing costs if you compare to other services like the AWS Transit Gateway. All right, now private link, what we saw also on the previous slide is that it can help you access load balanced resources. So you see that we still have a dependency on the network load balancer in the provider VPC. Now, what if you would like to access non-load balanced resources? Then we have released another type of endpoints, which is called the resource endpoints this time, and they are really there to help you access these non-load balanced resources, because now you can point directly to an IP, to a DNS name, or even to an ARN in the case of Amazon RDS. So some key takeaways about this. So you saw many ways to connect VPCs together. So the main thing you have to remember is that you don't have to pick a single one and apply that to all your VPCs. You can really mix and match them as your needs demand. Okay, let's talk a bit now about multi-region. And in fact, so we saw a situation with a single region. You could deploy your application in a first region, and then you would typically point Route 53 to this region. So then if you want to begin to use a second region, what you will typically do is to replicate the same architecture, same infrastructure in the second region, and you will point Route 53 to this second region. Now, Route 53 are many policies like latency, geolocation, geoproximity based, and they can really help you reduce latency to global clients. So what you could have is end users based in the UK could be redirected to the London region, and end users, for example, in the US could be redirected to a region in the US. But yeah, another benefit of multi-region is that it can improve your availability for sure, because if one region goes down, then you still have another one to rely on. Other requirement you can have is if you have, let's say, applications in two regions and you want that they can talk with each other, so you can consider AWS Transit Gateway inter-region peering, and in this case the traffic will continue to flow between the two regions on the AWS backbone. So a thing to pay attention to here is the latency between two regions, but you can monitor this latency from a tool which is called the Infrastructure Performance Tool. So it's accessible from the AWS console, and it can give you nice graphs about the history of the latency between two regions or two AZs. And now I'm going to leave the floor to Adam, who is going to give you more information about the well-architected CAT.
Hey folks. Can you all hear me? Marvelous. Okay, thanks for the introduction. So much of what Vincent was talking about was sort of cloud connectivity, how you connect things in AWS. I want to take a few minutes of your time to talk about hybrid connectivity, name resolution, security, and leave you with some best practices. The only person I haven't introduced is Garfield, the well-architected wizard cat. He's a UK domestic short-hair cat. He's 8 kilos in size, and in my home, he's very much the wizard. So look out for him, and he's lots of technical prowess on display today. So when thinking about connectivity to AWS, two of the services that customers are going to gravitate towards are VPN and Direct Connect. Site-to-site VPN is relatively straightforward to set up. This creates an end-to-end encrypted tunnel between an external location and the AWS VPC. We're only illustrating here virtual private gateway into VPC, but know that you can terminate a VPN on a transit gateway or a Cloud WAN CNE as well. There's two parts really. There's a logical piece and a physical piece. Logical piece is really your container for all your settings and things like that inside the VPN, and then the physical piece are the two physical tunnels that you build as part of that VPN. You should definitely connect both tunnels. You don't have to, but the advice here is that you absolutely do, because if there's an outage on the AWS side, then that would create an outage in terms of your VPN connectivity. The other thing is that failures don't just happen on the AWS side, they happen on your side too. So you should probably have some diversity in the equipment that you use. Now for customers that want perhaps higher bandwidth or lower latency and access to the AWS backbone, they might look at AWS Direct Connect. Two parts to AWS Direct Connect. There's a physical piece and a logical piece, as with the VPN. The physical piece is a cross-connect in a carrier-neutral facility, a point of presence. We have 140 of those on our backbone that can be from your equipment or partner equipment that's operating on your behalf. Once that's in place, there's a logical piece. That logical piece is the combination of a layer 2 VLAN and some IP addressing for sort of the BGP peering and the network address translation exchange. And that logical piece is sort of deployed against the virtual interface. And there are three types of interface on Direct Connect. The first is a private VIF. A private VIF will give you access to a single VPC or multiple VPCs if you're using a Direct Connect gateway, which you should. You should definitely use a Direct Connect gateway. This is all private communication. If you're connecting to hundreds, if not thousands of VPCs, you're going to want to use a transit VIF, which again will exchange private routing information, but it will give you a way to terminate on something like Transit Gateway or Cloud WAN. Now, if you want to talk to public addressing on the AWS backbone, you will use a public VIF. And by the way, that's an impressive backbone. So not only will you be able to get to all of the regions, and all the public IP information using AWS Direct Connect around 140 plus locations around the world, but that backbone is facilitated by 6 million kilometers of fiber optic cable that wraps the earth. So pretty impressive. We can get you from where you need to be, from where you are. What about resiliency? So we talked about resiliency for VPN. What about for Direct Connect? Well, resiliency can be thought of in sort of low, medium, and high, if you guess, and the way this is sort of facilitated is by the number of physical locations that you choose and the number of circuits you take. So a development and test environment will probably use something like 2 connections in one facility. And this will actually give you a 195 SLA from AWS. If you're looking for something higher than that, maybe a 3.9 SLA, what you would need to do is take at least 1 connection in 2 physical locations, 2 different POPs on our backbone. Bringing that forward, perhaps to maximum resiliency, you can see where this goes, multiple physical locations, multiple circuits. And yeah, so we have a wizard in the console actually that can help you put this all together. What about encryption? So the VPN actually is IPsec encryption, end-to-end, okay? So Direct Connect, the first thing to say is that with the border network that AWS provides, any communications that across or transit connections that we don't fully control are optically encrypted and encrypted at multiple layers by default. So for customers that want to have an encryption solution over Direct Connect, they can look at MACsec or 802.1ae, and this is near line rate encryption, so it's very performant. This is hop by hop encryption. So this is something a customer can turn on from their DMARC point all the way into the AWS cloud. There are other options too. So perhaps you might use a private IP VPN, and the way this works is you'd spin up a transit VIF, as we said before, it's one of the virtual interface types, and then you would create an attachment on the transit gateway that enabled a private VPN over that Direct Connect connection. The other thing you can do, of course, is use a public VIF, because we know that if you create a public VIF, we advertise the AWS backbone to you. So this, in effect, gives you the ability to create a Direct Connect connection and then an IPsec-based VPN to a public IP over the top of that. And of course, combining VPN and Direct Connect is possible. two. You can use one to back up the other. So perhaps Direct Connect is your principal modality for connecting to AWS, and you create an IPsec backup that might use another internet breakout, or indeed a public VIF on another connection. That's also possible too. So what about DNS? Let's do a brief refresher on DNS, how it works in AWS, then talk about the hybrid piece. So the first thing you have is a private hosted zone. This is a container of mappings of IP addresses to record types. And you apply this to the VPC. As a workload in that VPC, as part of your DHCP option set, which we're going to talk about in a second, you will know where you need to send that request. And if you're using IPv4, you will send that request to the .2 address at the base of the CIDR range attached to that VPC, or the :253 address if IP version 6. What that means is the workload talks to an inherent DNS resolver inside the VPC, gets that record back from that private hosted zone, and is able to make a connection to that endpoint. But what about if you have resources on-prem and in the cloud that need to mutually resolve each other and connect? Well, for that, there'll be a combination of using Route 53 resolver rules and endpoints. The rules, as described in this, or depicted in this table here, effectively show the mappings of forwarders. So you've got a name or a domain with an IP address that you're going to reach out to for resolution. That gets associated to a VPC. And then your workload is able to send the request as it did before to the .2 or the 253 resolver, look at that rule, and send that request on to where it needs to be. If you've got an external resource, it actually makes a connection in through this something called an inbound resolver endpoint. You see this flow here where the external DNS server made a connection in. The previous flow actually went out through something called an outbound endpoint. So to do mutually between both, you would need to have both inbound and outbound endpoints. Some anti-patterns to be aware of, okay? An anti-pattern, if you're not familiar, is something you could do, perhaps you shouldn't, all right? So DNS anti-pattern is actually build your own DNS resolvers on EC2. This was the way for a long, long time, but resolver effectively means that you don't have to do that as customers now. It's a highly efficient service that is designed for exactly this use case. So one anti-pattern is to build your own resolvers on EC2, and then update the DHCP options set to use those resolvers in the VPC. You can do this, but you just need to be aware that this can introduce, or will introduce, cross-AZ traffic and create some polarization depending on the binaries that are actually making that request. So operating systems operate in a different way. You might find that the first DNS resolver in that list gets sort of all the traffic and gets a bit polarized. The other anti-pattern to be aware of is actually using resolver in the wrong fashion. And that is to sort of centralize all of your endpoints in an account in a VPC. Put your private hosted zones into that VPC and attach them, and then use a configuration in the rules which effectively sends the request out of the outbound endpoint and hairpin it back in through the inbound endpoint. So it can be done. You probably shouldn't do this. If I go back one, this introduces cross-AZ traffic. It also increases your costs because there's a charge for the request across the endpoints. There's also a scenario where you can actually overwhelm the endpoints depending how busy your estate is. So I know what you're thinking. You're saying, Adam, what's the solution? What should we do? Well, the solution is Route 53 profiles. That's why we have this service. So again, it looks a bit like the previous diagram. You have your centralized endpoints. And you create a profile. And into that profile, you create resolver rules, logging configurations, firewall rules, that type of thing. You bind that into a profile, and you use a resource access manager to share that with different accounts and different VPCs. And then each individual VPC can make its own decisions about what it's doing. It doesn't necessarily rely on the central VPC with the endpoints. So some DNS takeaways: avoid building technical debt and using EC2 for your resolvers. Use the IaaS services, if you like, that are there built for you to take away that heavy lift. So AWS is doing much of the work here. And use the profile feature for resolution at scale. Now then, no talk at AWS would be complete without a word on security, and this one is no different. So I want to talk to you a little bit about security and how you can think about that. In terms of layered security, so the first thing I want to talk about is within the VPC. You have some primitives you can use here. The first thing is that security groups applied at the instance level and filtered down to the network interface are stateful firewalls. If you're not familiar with what that term means, it effectively means that intelligently the firewall permits return traffic without you having to do much work, which is a good thing. A very good primitive and security block to use. The next thing is a stateless firewall, and that is a NACL, a Network Access Control List. You have to be more specific about flows that go through this and traffic permissions based on IP addresses and ports and things like that, but it's another very good tool that you can apply at the subnet boundary. There's also quite an interesting advanced pattern here, which uses something called more specific routing, and that is inserting a firewall appliance between subnets, and you can do that. At the VPC boundary, as Vincent was talking about, using things like Transit Gateway and Cloud WAN, you're going to be using that service as sort of the medium to connect all your VPCs, and it gives you a really good opportunity to put firewall services in between those flows. So you can definitely do that. You can use Network Firewall, you can use Gateway Load Balancer with a third-party vendor, and also at the VPC boundary, you've got Route 53 DNS Firewall for marshalling and giving you some control over those requests that are perhaps leaving the VPC boundary. At the network edge, a layer 7 for building your applications. We have a web application firewall. This can be applied in things like CloudFront and against Elastic Load Balancer against your APIs. And there's a lot of great features in that you can use to mitigate threats. For distributed denial of service, there's two flavors. You've got Shield and Shield Advanced, and you can apply this in very similar places as well. So CloudFront, at your APIs, as well at the network edge. And bringing all this all together, you need an orchestration tool. So Firewall Manager is really good for this. So this enables you to have some central governance and central control over the policies that you create, how you sort of send those out and apply those across multiple accounts within your region. The other thing to talk about is security groups cross-referencing. This is actually a way to do zero trust. If you look at this architecture here, we have a 3-tier application, we have a front-end, middleware, and some database layer here. And each one of those layers actually has its own security group. So rather than having a security group that references ephemeral things like IPs that can change over time and are really difficult to keep up with, you can actually reference security groups. So the act of actually applying a security group to an entity and then referencing it within another gives you a form of zero trust. So definitely something that you should do. Also to note here, if you're using Transit Gateway today, security group referencing is supported in Transit Gateway in the ingress flow only. So great stuff. Traffic inspection patterns. 3 things to think about here: VPC to VPC inspection, egress filtering, and ingress filtering. So flows out, flows in, and between, east-west if you like. What I like to say on VPC to VPC inspection is consider whether you need it, okay? Adding firewalls into the flow adds complexity and cost and an overhead. So definitely it's an architectural decision as whether you actually need to do that. And also, as Vincent was talking about, some of the higher level services like Amazon VPC Lattice and Private Link and things like that, they enable you to open pinholes between VPCs today. So consider whether you actually need to have a packet level firewall between your VPCs. If you do, Transit Gateway or Cloud WAN can certainly be there to help you stitch that together. When thinking about accessing the internet, both sort of egress and ingress, some things to think about is whether your workloads are private, whether they're public, whether they're NATing, whether they're IPv6, whether they're not NATing, whether you're using a NAT gateway, and things like AWS Network Firewall and where that's going to be inserted in the traffic flow. So with all of that in mind, perhaps the first one to talk about is distributed egress, very common pattern for customers. Most accounts and VPCs control the destiny of how they build the filtering from an exit perspective, from the VPC going to the internet. One thing to be cognizant of here is the cost. The cost, the more infrastructure you deploy, there is a charge for that. And also you need to think about perhaps governance and orchestration, how you're going to bring all that together from a central perspective. But a very popular pattern. The inverse, or the alternate to that, if you like, is centralized egress. Again, another very popular pattern with customers. And this would be using something like Cloud WAN or Transit Gateway to focus traffic flows from all your different VPCs within a region, take them through a Transit Gateway type service or Cloud WAN type service through a firewall type device, and then onward to where they need to go to. Again, a very popular pattern. The trade-off here is that you need to be thinking about what it costs you to send that traffic through a Transit Gateway or a Cloud WAN. That's the trade-off to make. Okay, so you might gain something in terms of sort of focusing the flow through a central account or a central VPC, but you need to think about what the upside and the downside is based on your data transfer costs. What about connections from the internet in? as before, distributed ingress. Again, a very popular pattern and one that we recommend actually at AWS. It gives you the ability for accounts to control their own destiny in terms of how they connect. A lot of, there is some automation that is required here, especially if you're thinking about governance from a central perspective. So you just need to sort of balance that up. But certainly if you're a developer and you're building things like auto-scaling groups into your load balancers that are sort of, being referenced publicly, then this is a very, very good pattern. Perhaps one of the anti-patterns or patterns to be aware of when you're building that might cause some heartache for you, centralized ingress. This is one that we don't generally recommend because it has some caveats, but know that you can do it. It's somewhat of an anti-pattern, but know that it does work. The challenge with this pattern, and it looks very similar to the egress pattern, is that you use something like Transit Gateway or Cloud WAN to focus the traffic as it comes into your environment. It does mean that you're expanding your blast radius, so if there's an issue with any of the infrastructure that's bringing all these traffic flows in, that could cause an outage across multiple business units or multiple parts of your business. As a developer as well, things like auto-scaling groups don't work across multiple accounts today, so that means you're doing things like stacking load balancers together. So know that it does work, but it isn't always necessarily the pattern that we recommend. So for takeaways for this, for egress, both centralized and decentralized are patterns that you can use and that we recommend. For ingress, prefer the distributed approach. But know that you can do it the other way, but there are some architectural considerations to be made. So when designing VPCs, know that VPCs are designed for cloud scale. You can have thousands of compute endpoints inside VPCs. They scale very, very well. We give you some flexibility over the CIDR ranges that you can apply. So you have your primary CIDR blocks that you'll apply to VPC, but know that you can add more. If you're running out of IPs, perhaps you've got container sprawl or something like that. There's some sort of clever architectures you can do where you have non-routable subnets with different CIDR ranges inside those VPCs as well. So yeah, but allow for growth and thinking about automation and perhaps some governance over how you slice up your IP addressing for those VPCs. Perhaps something like IPAM or IP Address Manager would be a good tool for you to look at. Implementing infrastructure at scale. So you should use ISE. The particular choice of language that you choose here is entirely up to you. As a customer, you should choose the service that works best for you, whether that's Terraform, whether that's CloudFormation, whether that's CDK with some wrapper around it. It doesn't matter. It matters that it works for you inside your business. Perhaps one way to think about this is the things that are common across perhaps 70% of the business, maybe 70%, would be things like Transit Gateway deployments or Cloud WAN, things like that. And you can deploy those as a stack. And then your electives are things that business units can choose themselves. So these are things that you can build into modules and have inside a service catalog for customers to choose from. And last but not least, think like an AWS network architect. I would like to leave with you the thought that networking is not just a platform service, it is a force for innovation to drive value within your business. Planned and designed and deployed efficiently, it can make a market improvement. Don't build in a vacuum. Make sure you include the right stakeholders in your decisions and your processes, and you're working backwards from the problems at hand. Allow for growth. Change does happen. You don't have to get everything right on day one, and harness the ability of cloud to, break some of the rules, right? It's very easy in AWS to build a global network in minutes. It's very hard to do that in the real world, so outside of the cloud. So use cloud for, and use it for its advantages. Automate where practical. You don't have to over-automate, but make sure you're thinking about it in everything that you deploy. And the last thing to say here is that identity is more than an IP address. So be thinking zero trust in your deployments today. If you've been inspired by any of this today, you can set up a Skill Builder account. You can do that now on the website. And on behalf of Vincent, myself, and Garfield, the Wizard Cat, I'd like to thank you for your attention. I hope it's been valuable and you've had a good summit, and go build.